This is reading scientific notation. Scientific notation is used to write very small and very large numbers in a more compact way. For example, here we have a very small number with a lot of zeros. In scientific notation, this number can be written as 2.3 times 10 to the negative 13th. Here we have a very large number, lots of zeros again. This can be written as 1.24 times 10 to the 16th. A number that is written in scientific notation is represented as the product of a factor times the power of 10. Basically, that means it's a multiplication problem that includes a factor being multiplied by some power of 10. The factor itself has to be greater than or equal to 1, but less than 10. So this first factor here, greater than or equal to 1, but less than 10. For the power, the exponent must be an integer. You can't have an exponent that is either a fraction or a decimal. It must be an integer. So in example 1, we're going to identify whether some of these numbers are written in scientific notation and explain why yes they are or no they're not. So this first one is a yes. I look at my factor, and it's a number that is greater than or equal to 1 but less than 10, 5.9, between 1 and 10. And my exponent is an integer. It's a factor times a power of 10. In this case, this one is a no. It is a factor times a power of 10, but the factor is less than 1, which is not okay for scientific notation. The absolute value of our exponent indicates how many places we're going to move our decimal. So if the exponent is negative, that indicates we're going to move our decimal to the left. If our exponent is positive, we're going to be moving our decimal to the right. And that's in order to take a number written in scientific notation and change it back to its standard form. So here we've got numbers in scientific notation, but I want to know what was the original number. What's the actual number here? So our exponent tells us how many times to move our decimal, and whether it's positive or negative tells us what direction. So the factor here is 3.22. Since my exponent is 4, my decimal is going to be moving 4 spaces. And since it's a negative 4, we're going to be moving our decimal to the left. So I'm going to move this decimal 1, 2, 3, 4 spots. If I've got empty slots there, I'm going to fill them in with zeros. This decimal is now gone. So my original number would be 0.000322. Here I have an exponent of 5, which means my decimal needs to move 5 times, but this time the number is positive, which means that I'm going to be moving the decimal to the right. 1, 2, 3, 4, 5 spots. So this is the old decimal, this is the new. I fill in empty spots with zeros, and my new number is 790,000. When I have a negative number, it's going to result, a negative exponent, it's going to result in a small number. When I have a positive exponent, it's going to result in a big number. Objects that have less density than water float, while objects that have greater density than water will sink. So here we're given some densities of different objects, a brick, an apple, and of course the water, in scientific notation, and we want to know what will happen to them when we place this brick and apple into the bucket of water. So first of all, let's figure out the density of water. So water is 1.0 times 10 to the third power. That means I'm going to be moving my decimal 3 spots to the right. So water has a density of 1,000 kilograms per cubic meter. Now I'm going to do the same thing for the brick. For my brick, My factor was 1.84, and I'm also going to move my decimal 3 spots, this time to the right. So I get 1,840. The apple's factor is 6.41. My exponent is 2, I'm going to move it 2 to the right. So I get 641. So the water has a density of 1,000 kilograms per cubic meter. The brick's density is greater than that, so the brick will sink. The apple's density is less than the water, so the apple will float when you put it in. Let's look at our last problem here. A female flea consumes about 1.4 times 10 to the negative 5th liter of blood per day. If your dog has 100 female fleas living on it, gross, how much blood do the fleas consume per day? So they're kind of like mosquitoes. They bite you and drink your blood. So if they drink 1.4 times 10 to the negative 5th liters per day, and there's 100 of them, I'll have to multiply that by 100. Well, the first thing I'm going to do is change this back into a regular number. So 1.4, I'm going to move my decimal 5 times, this time to the left. 1, 2, 3, 4, 5. Add in some zeros here. So my number for the amount of blood they drink is 0.000014 liters per day. Oops. Times 100 of them results in their total being 0.0014 liters of blood drank per day from your dog.